Hello, I am Dr. Bob. I am going to show you how to set up the CS sample plates to be completely flat when -SP is 0 degrees and fully vertical when +SP is 90 degrees. If the 0 degree setting is not correct, the sample plates could crash into the CS frame or each other. If the 90 degree setting is not correct, the sample plates could crash into each other. The minimum -SP for the CS is 0 degrees. The maximum +SP for the CS is 90 degrees. If you go beyond either of those limits, you could damage the CS. If the settings are angles other than 0 degrees and 90 degrees, and even though the sample plates cannot crash, if they are not set up properly, your measurements will not be correct. In that case, I would suggest you first do this setup for 0 degrees and 90 degrees, and then change your -SP and +SP for your specific test. Let me illustrate the problems. Here's the case where the sample plates can crash into the CS frame if -SP equals 0 is not correct. This example is with a large model CS. The red arrows show where the plates are actually touching the frame. The next case shows a standard size CS with a small folding radius. In this case, the sample plates can actually crash into each other below the line of sight. The lower edges of the sample plates collide. In this photo, I removed the plates to make it easier to see where the plates will touch. The red arrow shows the location. The next case shows how the sample plate can crash into each other if +SP equals 90 degrees is not correct. And in this case, the sample plates could fall off inside the machine and jam the mechanism. Either kind of crash can cause a motor error. What happens is that the plates crash, the motor tries to keep moving, but it cannot, and the motor shuts down and shows an error on the touch panel. To illustrate the setup, I will use the motor drive unit DMLHP and the standard CS. We will start with the two pieces separated, the clamshell jig and the motor drive unit. The holding beams are on the CS to hold the CS mechanism in the horizontal or flat position. I have my straight edge handy to check for flatness at 0 degrees and the proper Allen wrench to tighten the coupling. Other possible couplings are also on the bench. When should you do this setup? Well, the first time is when you first acquire the motor and the CS jig. It might be new or it might have been used by somebody else. In any event, do not trust the setup. Do your own from the beginning. A second time would be any time the CS has been removed from the motor and you are reattaching it. In that case, you should do this full setup. You might think that everything is the same as when they were attached, but you cannot count on that. A third case would be if you were encountering any unexpected behavior, like a motor error. The setup might be at fault. In this case, you really need to do a new setup from the beginning. If the coupling is not tight enough, the motor shaft and the CS shaft can slip, causing this setup to be incorrect. A fourth case is when the sample plates ever crash. You really need to do a new setup from the beginning. I like to make sure my motor is correct first. With no jig attached to the motor, I run the motor using the jog button all the way to one end and then all the way to the other end. I am not talking about 0 degrees and 90 degrees, but the full range of the motor. In the case of the HP, the full range is -270 degrees to +270 degrees. You might need to change the limits on the settings page to -270 degrees and +270 degrees. To change the limits, you will need to enter the password first. The default password is 0000. If the password has been changed, you will have to know what it is. And the -SP and +SP settings on the home page will have to be set for -270 degrees and +270 degrees. First, I make sure no jig is attached to the motor. Then I would use the -jog button to go all the way to -270 degrees, making sure the touch panel shows -270 degrees. Then I hold the +jog button to go all the way to 270 degrees, going through 0 degrees, making sure the touch panel shows 270 degrees. Then I hold the 0 jog button until the motor reaches 0 degrees, making sure the touch panel shows 0 degrees. If the touch panel did not show the values of -270 degrees and 270 degrees and 0 degrees, repeat those three steps. Next, on the motor touch panel, set -SP to 0 degrees and set +SP to 90 degrees. Check to make sure the motor is still at 0 degrees. If not, bring it to 0 degrees with the minus jog button. I have the holding beam slightly loose on the CS, so I can use a straight edge for the perfect flatness. You cannot count on the holding beams to hold the sample plates perfectly flat. I always use a straight edge to make sure the sample plates are flat. Push the CS up to the motor, making sure the CS and the motor are properly aligned. Normally I have the coupling already tight on the CS shaft and in the proper position. Push the CS into the joint bracket. The coupling should go over the motor shaft. Slightly shift the position of the CS as needed to make the coupling easily go over the motor shaft. Push the CS as far as it can go into the joint bracket. The coupling should be very close to the motor enclosure, but not actually touching. If the coupling position on the motor shaft is not close enough to the motor enclosure, or if the coupling is touching the motor enclosure, then it will be necessary to adjust this coupling on the CS. Loosen the coupling on the CS shaft with a 2.5 mm Allen wrench. Newer couplings might use a 3 mm or 4 mm or even a 5 mm Allen wrench. The coupling I am using here needs a 4 mm Allen wrench. Then push the CS as far as it can go into the joint bracket. The coupling should go over the motor shaft. You should be able to move the coupling back and forth easily. If not, slightly shift the position of the CS to make it easy. Move the coupling so it is very close to the motor enclosure, but not touching. And here's a tip from Yuasa Engineering to get good spacing. Gently hold a doubled sheet of paper between the coupling and the motor enclosure. Then tighten the coupling on the CS shaft. Tighten to 1.5 Newton meters, that's about 1.1 foot-pounds. Do not over-tighten the screw. Now check with a single sheet to make sure it fits. Now I am ready to tighten the coupling screw on the motor shaft. But first let's look at the sample plates. I left the holding beams loose. The plates can move above and below 0 degrees. Put the straight edge across the plates. At one end of the looseness, you can see that the straight edge is high at the center. At the other end, you can see that the straight edge is high at the outside. But if I hold down on the straight edge, it is flat all across. I will tighten the coupling screw on the motor shaft while keeping the plates flat with the straight edge. Again, tighten to 1.5 Newton meters. Do not over-tighten the screw. But you do need to make sure the coupling is tight or the shafts can slip inside the coupling. Remove the holding beams. Use the plus jog button to make the plates go vertical. I want to use a slow travel at the top, so I switch into low speed jog. I am using a 1 mm shim total. The folding radius would be 0.5 millimeters. The plates are clearly too far apart. With the ruler, it looks like more than 1 millimeter. Some people like to use the same width shim to check at the top. I have a 1 millimeter shim and it is loose. Something is wrong. I move the plates back to 0 degrees and check for flatness. Slow down as you reach 0 degrees. The plates appear to be flat, but let me set them again. Put the straight edge across the plates and loosen the motor shaft screw. Hold the plates flat with the straight edge. I will tighten the motor screw and the CS screw a little tighter than I did before. Use the plus jog to go to vertical. Slow down at the end. The plates look good. Check with the shim. If the plates are parallel, go back to 0 degrees to make sure they are still flat. Slow down at the end. They are flat. Let's try the vertical again. Low speed at the end. It looks good. Go back to 0 degrees and slow at the end. It is flat. I am finished with this setup. I must have done something wrong the first time. Perhaps I did not have the coupling screws tight enough. But to illustrate another possibility, let's pretend the plates were not parallel. So I go back to vertical, slowing at the end. Suppose the plates were closer together than 1 millimeter. The shim does not fit. Then I would need to compensate a small amount by changing plus SP to be slightly different from 90 degrees. I will need to set it to the value that results in parallel plates. If the holding plates were not parallel, I would change plus SP in 1/10 degree steps, moving the plates slowly back and forth each time I change to find the plus SP setting where the plates are parallel. To demonstrate this, I will set plus SP to be 89.9 degrees. Then I would use the minus jog button to separate the plates using the low speed jog. Then I would use the plus jog button to slowly bring the plates back together. It looks good. The shim fits. If the plates are parallel, then I would go back to 0 degrees to make sure they are still flat. Always slow down at the end. And they are flat. Then go back to vertical to confirm, slowing at the end. The shim fits. Then back to flat to confirm, slowing at the end. The plates are flat. That would complete our setup. We would leave plus SP at the setting where the plates are parallel, and we would leave minus SP at 0 degrees, the setting where the plates are flat. So here's our procedure. But remember, before attaching the CS jig, always do the motor check. The procedure, step 1, get the sample plates flat at 0 degrees. Step 2, check the sample plates at 90 degrees. Step 3, if the sample plates are parallel at 90 degrees, check at 0 degrees. If the sample plates are still flat at 0 degrees, you are finished. If the sample plates were not parallel at 90 degrees in step 2, check at 0 degrees. If the sample plates are not flat at 0 degrees, you probably did not tighten the coupling sufficiently. Go back to step 1. Keep doing steps 1 through 6 until the sample plates are always parallel at 90 degrees and the sample plates are always flat at 0 degrees. If the sample plates are always flat at 0 degrees and the sample plates are always the same incorrect separation at 90 degrees, you will compensate by changing plus SP in 1/10 degree steps until the sample plates are always flat at 0 degrees and the sample plates are always parallel at plus SP. When you find a plus SP setting such that the sample plates are always parallel at plus SP and the sample plates are always flat at minus SP equals 0 degrees, you are finished. When you are finished with the setup as described here, operate the machine slowly with the jog buttons to confirm the holding plates move slowly and reach 0 degrees with the holding plates horizontal and 90 degrees with the holding plates parallel. I normally do this at least 2 times to make sure I am satisfied. The CS sample plate setup is now complete and we can begin testing. You can find all our setup videos at bayflextechnologies.com/setup.